You guys can see 10 and 12 and 14. Let me give you a second. 10 should have been B, 12 should have been F, 14 should have been C, and 9, 11, and 13 you should know because it's an odd. True? True. Cool to scroll down? Yeah. 36, he has a bit more going on. Let me give you a second. 36, he has a bit more going on. Let me give you a second. All right, those of you that aren't checking right now, your goal tonight, get caught up. Your goal tonight, get caught up as much as possible. Don't worry, there's a few of you, I see you. Probably very different reasons as to why you're behind. Maybe go home, take a nap, then get caught up. But have someone wake you up from said nap or else it's not going to maybe happen. Sometimes a power nap, it depends on your personality. Sometimes a power nap can give you the energy to keep going as opposed to like doing this all night and getting nothing done. But sometimes it can keep you from getting anything done.
Yeah, for me, I just make sure that it's only like 15 to 25 minutes.
In that range, and then...
Even if I don't fall asleep, just lying in bed.
Just kind of...
Yeah,
I understand.
Just give your brain a break.
So I'm guessing we're done? We're all just talking. All right, go team. Any questions? Going once. Going twice. Uh-oh, you guys are acting like pre-cal today. Like half of you have it, and you're checking, half of you are just talking and just ignoring me. It's a good day. It's a Monday from a very busy week. Kiddos, section 10.3, it's a common. It's not huge, I don't really think. But it's very similar in the sense of size and in the sense of skills, that we need to figure out some special equations for ellipses, kind of like we did with parabolas. Figure out some special characteristics like foci. Wait, why did I say foci? For a parabola, it was focus. What's the difference? Parabola only has one. It's like the tongue in the mouth. It's trying to eat it. Well, or the fly in the whatever. Anyway, right? The focus is inside the mouth. It's trying to eat the one focus. But for an ellipse, we saw on Friday, how many foci? 2. And the farther apart they are, the more elliptical or stretched it is. And if they're far apart on the horizontal, it's stretched horizontally. If they're far apart on the vertical, it's stretched vertically, right?
Yeah.
That's about all we got. Nope. We talked about major and minor. Which one's longer, the major or the minor? Well, don't answer horizontal or vertical because that depends. You're totally right. But which one do you think would name the longer one, the major or the minor?
Major.
Exactly. So major is the longer one, minor is the smaller one. Sound good? Cool. Wait, why am I saying there are 2 different radii or axes, whereas a circle only has 1 radius? It's not, I guess we could say it's symmetrical, but it's not even all the way around. I put it that way. Because it's been squished, it's going to be longer one direction and shorter the other. Is that cool? Go team. Guys, let's pray real quick. You guys are just like, meh, for one reason or another. So, you've made it through the weekend. For one reason or another, that's an accomplishment. For some of you more than others, because you were performing. For others of you, you're just had a lot going on. Or you're just tired and have a lot to face this week. So let's pray quick and let's get going. Father, Lord, I praise you, first of all, for the gift of today, even though it's a Monday. We need to be thankful in all things because we can trust you in all things. And so even on this Monday when we're tired, when the play people are just wiped out, when the rest of the kids, for one reason or another, just kind of, today's a blah day, Lord, just pray that we can look beyond what's kind of clouding our vision right now, look up and see you and see your great, gracious, loving plan for all of us. We might not know exactly what it is, but we do know that you're in control and in charge. So increase our faith today, Lord. Let us see you clearer, better, and in a way that we can strive harder and longer, but also love those around us because we know that we have been loved by you. Lord, I pray for Nalani and for Nicole. And I think Brandon got in here, but watch over them as maybe they're trying to get to school or Nicole's not feeling well. And for the rest of the kids, just keep them strong, protect them, and let us get some work done well for your glory. In Jesus' name, amen. All right, kiddos. Let's recharge. Let's go back to our notes. Checking is done. It was recorded. I think I'm saying yes to that. Okay. Let me get my ellipses up. A squish circle. Sort of, kind of, maybe. You guys were having fun drawing your diagrams on Friday. Actually, we're kind of just judging each other's, which is a little rough, but oh well. Hey, why is there a highlighted box up there? He's important. Because what is so special about C to C? C to C. What's so special or important about the C with an ellipse? Do you see him? What is he similar to in parabola, school kids? If he's the distance to the focus from the center, what is he very similar to in parabolas? Yeah, he's very similar to P, right? Because P would measure from the vertex to the focus for a parabola, but now we're measuring from the center to the foci, so we're going one way, going to the right if it's a major axis that's horizontal, right, so longer horizontal. We're going right and then left if it's up and then down. Now, did I say that there were some formulas that you could memorize if you wanted to? You guys see the little baby formulas? There are little baby formulas that you could memorize as far as how to get to the focus, or I should say the foci. One focus, one direction, one focus the other. So let me give you guys a couple seconds because some of you might not have written down those formulas on Friday. If you're a formula person, that might help. If you're not, but you're like, I'm not sure I like this stuff, maybe it'll also help. However, those aren't the only pieces of an ellipse that we need to know. Luca.
Just for curiosity,
Sure.
does it have any trigonometry involved in this A, B, and C? Because if it's put the B squared to the other side, then you have A squared equals B squared plus C squared.
What are you thinking? Pythagorean, maybe?
Yeah.
Well, first of all, hold on. Who is A and B? Anybody know?
Yeah. Half of the major and half of the minor.
Yes, kind of like a major radius and a minor radius. Let's go ahead and take a second and define A and B, okay? So, A and B, in this picture, I think A comes first. Is there a better way of saying that? A comes first. Well, I was gonna start highlighting things. I was trying to think of another way of saying that A is the major, but A is always. So A is specifically, if I was to get my green, give me a different color, don't judge too much, okay. If I was to measure the distance from the center to the outermost edge, that would be A, okay. And so the distance, the distance would be from the center to the outer edge. So technically, couldn't we make a little formula for this guy also? And couldn't we say this is, how would I write this formula?
0.
Not 0, because I don't know exactly how.
2C0.
C.
Does it have anything to do with C?
No.
Where do you measure A out from? Yeah, you measure out from the vertex. And so, question, isn't horizontal an x-coordinate? So what's the initial x-coordinate? And then how much more am I going? A. So wouldn't it just be h plus A instead of h plus C? K stays the same, the y stays the same. Does that make sense? So if I wanted to go out to the outermost edge of the ellipse, which they might ask you every now and then, you could go by adding A, or how would I go back the other way? Yeah, subtracting K, so it'd be subtracting A. H minus AK. If A is the distance across, what do you guys think is the distance up? Ooh, but it's not going to be the A though. Yeah, good. So A is going to label, if we want to label it now, A is going to be our major. Major axis is like the entire thing. I kind of like calling it the major radius, not because it's an actual radius for a circle that goes all the way around, but it's like half the distance like a radius. Does that kind of make sense? So I like to call it the major radius because it's half the distance. So then what am I going to call B? Well, it's just going to be the minor radius, yeah. So if I come down here, I would go ahead and say this distance is going going to be B. So how would we label this top point, kiddos?
H K plus B.
Good, you need to add it to the K, right? So this would be, the X stays the same. Plus because it's going up, right? And then down here I'm going to have exact same thing, but,
K plus B.
oh, thanks, I put the A, silly me. What was I thinking? It's a Monday for me too. And then down here I would have H stays the same, K minus B. Yeah? That's pretty much every single part to an ellipse you might possibly want to know in one picture. What's going to change when we go over to the vertically oriented one? What do you guys think? How am I going to change? Yeah, so instead of the A going horizontal, what's going to happen in this picture? Let me get my other highlighter. There we go. A is just going to go this way instead. And so my points are going to switch too, right? So instead of being H plus A, now it's going to be K plus A. And then down here, instead of being K minus B, it's just going to be K minus A. So even though we're writing lots of formulas, hopefully you guys kind of see how it all comes back to the logic of understanding that A is half the distance of the longer axis, whichever that one is. A is half the distance, and so whenever you add up, you're adding to the y's. Whenever you subtract vertically, you're subtracting from the y's. Whenever you add horizontally, what are you adding to? You're adding to the x value, which is the h, not a. I did it again. Struggle. Who's supposed to be there instead? Y stays the same, and if I go to the other side, it's all patterns. Just understanding pieces and being able to move with those pieces. If you want to do the logical, graphical, puzzling sort of way instead of the memorizing sort of way. But you guys have the formulas if you want to do it with the memorizing. Now, kiddos, I'm pretty sure I have some of this written in snazzy. Oh, I guess I don't really, so I'm glad we filled it in there. We talk about eccentricity, but first of all, let's go ahead and try an example. All right, they gave us a picture. They gave us an ellipse. It's already made. We're supposed to come up with an equation. So I want you guys to get the example down. Then I want you to go back in your notes and find the example, not the example, the formula, the setup, the standard form of an ellipse for us to use. Make sure I get some air going on here. It's getting stuffy. Ugh. Anybody do anything fun for April Fool's Day?
Chocolate.
Oh, you went and visited? No good jokes, really? High schoolers like you?
I would be chocolate.
What?
Everyone sounds nervous.
Because everyone's too lazy when they're just at home. Like one of my old students
I
posted,
tried to cut back up, but she knew right away. So I was like,
are we
oh, dang,
making sure
alright.
it's April Fool's? And I was like, okay, that's funny. Calculus kids wanted me to cancel right when we were about to start and say April Fool's. I sadly couldn't go.
Cam Fuchs, he edited a picture of his email, and he put that Mrs. Cameron was changing the prom day to April 15th, and to the Reagan Library. He got like everyone.
Are you serious?
We were all freaking out.
That is hilarious.
It's actually really
That
funny.
is really funny. Good job, Cam.
He did a perfect addition.
It was impressive.
Yeah.
Alright. That's all we got. Alright, cool. kids. What formula are we gonna use?
X.
Did you guys go back and look at it? Both of them start with what? An X or a Y?
Yes.
Oh, both of them? Oh, okay, that's cool. So we're doing X minus H. I'm just saying, like, it's kind of cool when that doesn't change, right? And doesn't it kind of look like a circle because it kind of is a circle, but squished? So we have the X minus H quantity squared, Y minus K quantity squared. What's different? They're over sum. Equals 1. Why would it be A and B and not B and A?
Because if it was B and A, that would mean that the foci are going, you know, they're flying instead of.
They're flying instead of running.
The major axis.
Yeah, the major axis is horizontal is probably the easiest way to say, right? The longest, or if we want to do it this way, I made the major axis green, right? Couldn't I say A is going to go that way? True? So B goes the other way? Alright, so then technically we would have over A squared, yeah? Oops, I'm just writing colors now. Over A squared, and then B squared. So let's start plugging and chugging. What's something we know?
The vertex.
The vertex. I don't call it the vertex though. Technically it's the
Center.
center. There we go. Not foci. We haven't found them yet. But we know the center, and the center is where?
Zero,
Origin.
Okay, so that's easy. X minus 0 quantity squared plus Y minus 0 quantity squared equals 1. I need somebody squared in the bottom of the x's and somebody squared in the bottom of the y's. Not 4. Remember?
1 squared.
A is just 2, whereas B is just... No, not again. Come on. It's been good today. Oh, it's done.
I think it's always in the same time as the.
I don't know why. Must be some teacher using all the...
If it does it again at like 7 at 10:30,
Oh. Why would you?
you know it's kind of time.
He watches like...
Art always watches that. They have to be like intense, so it's like tired.
Because remember A is not
Like the 100-acre woods attack.
Oh, I was just filling in and the square was on the outside. So I thought you meant 4 from the distance all the way across and then 16. Well, it's an E for effort and an F for success. Yay, go to the next one.
We're still. George, Amanda Johnson, Amanda the Bessarian, Gerardo, what's his face? Jackie.
Oh, for BC? Is that what you guys talking about?
They have to get here.
Everyone in our school got denied to USC.
But the other day we were like last year we were like your school's really big, like right next.
Big time.
Alright, kiddos, so we were able to think about how the major axis would be on the horizontal. It's trying. This distance is what again? That's the A, the major radius technically, and that's 2. And then what's the height or the distance of that one? That's 3/2, which is B. So then when we go over here to plug it in, we do have our x minus 0 squared. All over, who's down there? 2 squared. Plus y minus 0 squared, just think vertical, right? What would that be? 3 over 2 quantity squared, which would be 9 over 4 equals 1. Oh, it's gorgeous. Leave it. Kinda. But they're going to simplify it. And if it was a multiple choice, the multiple choice would be simplified. So how are we going to simplify this? The standard form is technically, I mean, this is good clue version form. We can do this, right?
Yeah.
4 over 4 plus 9. 9. Oh, my bad.
Right?
Oh,
When you divide by a fraction, you multiply by the reciprocal.
that makes sense.
Now, how can we make it even better? Common denominators, yeah, we can get 36 and 36, right? So we multiply by 9 over 9. You guys okay if I jump?
Jumpity jump jump.
Jumpity jump jump jump. Back to sequences and series. 9 over 36 is 1 over 4, that's good. What are we going to multiply top and bottom to get this in 36? So that'd be a 16y squared, right? What was the point of all of that? Just make it look nice? Didn't I just multiply both sides by 36?
Yeah.
No, don't go factoring, because you're going to be killing the puppy. If it was a minus, we could do difference of squares. But plus is impossible. Nope, 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 because if you go to square root, remember, we can't factor this. It's a plus, not a minus, not a difference of squares. It's a sum. Impossible. But we can get it in nice, pretty standard form, like I'm sure they would probably like. You guys go to the beginning of, was it 10.2? The one where we did all the pictures of the cones and we sliced them and stuff, remember? The bottom said standard form was ax squared plus bxy plus cy squared plus dx plus dy plus half equals 0. Anyway. This one's all right. That's what the book might like. I technically like this one.
Yay.
Because this is the one that shows it in the nice standard form. I can see the vertex. I can kind of see the b. The b is kind of hard though, guys, when it's fractional. Because to simplify it, it kind of gets all mixed up into the problem. So beware of the fractions. If it's given to you like this, you're going to have to get it like that to find the 3/2. But I'm getting you ready for a problem that we're not even on yet.
Oh.
So you ready for another example? Spice. Sugar and spice? Everything nice? Alright, here we go. Next example. The side comments, though, this class. Ready, set, Start pondering this one. You have a picture, but it seems like it's missing some stuff. I see foci, but I don't see the vertices on the major and minor axis. I don't think you know A, but you do know C. Take a second. Show a picture of what you know. Take a second. Show a picture of what you know.
Well,
You know
the
C.
origin. No, the foci.
You know the foci, which means you know C, right?
Yes, we do. And we know.
You know C, and if you look at the graph really well, you can tell it's A.
For sure, for sure?
No.
Oh. Try to get our example done in the notes that I have. So.
B seems to be over 3 at the top, another 1, -1.
Plus 16y squared minus 36 equals 0.
It's like 3 and 1 1/4. I don't know, but look, A goes over the 3. It look really well.
No, boy.
Let me see if I can get mine up. Maybe it's working.
That was right.
Ooh, what they give you in a hint in the paragraph that some of you didn't even think to read.
Oh, 6.
Oh!
Major axis.
Look at that. Things hidden in the directions you should have read. Wait a minute. I think we should always know to read directions, silly goofs. Alright, so, what do we know so far? Did I trick you? Okay, major axis. From the picture, can you tell if that's horizontal or vertical? Horizontal. Okay. So I know that the distance, oops, let's undo. The distance is 6, right? So does that mean that this is, let's see, 6 comma 1?
No.
No, the distance is 6. And where are you going out from?
The origin.
Careful, the center, right? So if you go over 6 from 2, 1, can anybody tell what that new point would be? 8, 1, good.
Isn't the whole axis 6?
Yeah.
You label that A is 6.
Major, oh, I forgot. They call axis the whole thing. I call radius the half thing. Major axis. Good note. Whole thing. So what's the struggle of the whole thing? We don't want the whole thing, do we? What do we want? Half. So what would half be? 3. So what would this point be? Does that make more sense? 3, 4, 5. Yeah. Okay, so we know that A is equal to 3. What else do we know? We know the foci. What's the distance between the foci?
Oh, then you can find B.
Wouldn't that just be 2? Does that make sense? How far? We'll look at the x values because it's horizontal. What's 4 minus 2? What's the distance? 2. So we know that A is equal to 3, C is equal to 2. Don't we know that we should be plugging into our little x minus, can I just throw the 2 in, guys? Is that cool? Why am I throwing in the 2? That's the center, right? So what would I throw in for y? Y minus 1, good, squared, all over, equals 1. We already know the 3, so we can plug that puppy in, and it should be under the x. How come? Because the major is, yeah, horizontal. But we really need to know what b is, right? So we figured out that a is equal to 3. We got that one. If we have a and if we have c, how on earth can we find b, guys?
C squared equals...
Yeah, you forget so soon. The highlighted box. The highlighted box, what's the formula for ellipses? C squared equals? A squared minus b squared. So let's plug in a little formula and say, hey, no big deal, we can solve for it, right? No big deal, we can solve for it. C squared, 4, is equal to b squared. No, a squared.
A squared minus B squared.
Right?
It's square root.
Now, technically you could think plus or minus, right? But if we're going to square it anyway, it's not going to make a big difference. And number 2, a and b are always positive numbers. So now that we know b, can we go ahead and say, yay, let's plug them in, plug them in? So it'd be square root of 5 squared, and Creator's already simplifying and saying, hey, what's a square root squared?
B can be plus or minus 5?
Doesn't need to be. A and b are always positive. Because it's just a distance. Yeah, so we would just have y minus 1 quantity squared over 5. And then x minus 2 quantity squared all over 9 equals 1. Now guys, that is a good form. But if they wanted true their version of standard form, what would we have to do? Ugh, really?
Yeah.
Common denominator, wouldn't that be 45?
Yeah.
Oh, that's kind of messy. Couldn't we just multiply both sides by 45?
Yeah.
That'd be snazzy. So if we do 45 times this side of x minus 2, let's go ahead and FOIL it out. We have to eventually anyway. So x squared minus 4x plus 4 over 9 plus. This is my way of not having to get common denominators. You guys see why not? How am I going to keep going? Yeah, distribute the 45. Well, what happens when you distribute the 45 to the 9? To the over 9. Isn't that just going to be 5 times? And then what happens? I distribute the 45 These would just go in parentheses. Over 5. And that's just 9 times. Now, once again, you could have gotten common denominators. You could have added them together, then you could have multiplied 45 on the other side. I'm just showing you sometimes there are other ways of doing things. Where are we at? Ugh. We got a 5x squared over here. We have a 20x. We have a 20. You guys are double checking my math, right? Okay. There's no xy term. Got him. We have the x term, right? Then we have the y term. 20 plus 9 is 29. Minus 45, that needs to come over. 16? No, minus 16. Now, which one do we like better if we had to get the graph ourselves? Hopefully you guys would be like, yeah, please, 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 please. Because how much completing the square would this one need? A lot. No, it's not impossible. It would just be kind of a mess. But are the two the exact same thing technically? Yeah, just different forms. Just different forms. Oh, he is counting. Ah! Oh no!
Oh no.
What'd they do?
They did the opposite.
They gave us standard form and we have to go back to the next form or else, yeah, no, we're not getting any of that until we undo this.
Who is she?
That's alright, we just got there ourselves. Shouldn't it be easy to go back?
Yeah.
Strategies, you guys ready? Number 1, get rid of the 37. Way too many things have gone into him. We don't know what was there to begin with. Get rid of the 37. Plus blank. I think that's for a reason. Group your x squareds or your x terms together because they were together until we moved it all around.
Here we go.
Wait a minute. Can't a 9 come out of both of those?
Yeah.
Oh, that sounds nice. Maybe we should have done that first. Here's our x squareds. I see a 9 in common, so let's go ahead and get out that common 9.
9 and x for common.
Now I have my y squareds. I see a common 4, yeah? Remember, in complete the square, you need a leading coefficient of 1 anyway. So we had to think about what was in common between these two and factor out what was in common between these two and factor out, right? If you want, we could put 2 separate blanks over here on the right-hand side. It's going to be numbers I can combine. But if you want to see clearly what's going on, that works. 2, complete the square. Hopefully you'll know it by the end of this year. We take who?
Half of the second term.
Half of the middle, so half of negative 6 is
Square it.
negative 3, and then, yeah. So take negative 6, cut it in half, and then square it, right?
Mm-hmm.
So we would take negative 6 over 2 squared. That'd be negative 3 squared is 9, right? So why on earth am I putting an 81 over there?
9 times 9.
When I put a 9 in that spot, what does it end up adding to the entire side? 81. Does that make sense? You guys, fill in the last 2 blanks. I'll do them slowly, little by little, giving you time.
Ooh. Is the team that I have, one of them is, no wait, one of them you have factored out a 9, the other one you have a 4. Did you know the horizontal it has the major axis.
Yes. Yeah. For the major axis, you just ask yourself which one's biggest. Although maybe it's not as horizontal as you may think.
Oh, because it's 1/9. Oh.
Wait, is it 144? Double check my math. 70, 81, right? You guys just like
I'm
it's
just
perfect square.
trying to
Is it
mental
right?
math this.
It's correct.
See, I'm just doing this plus this. So I'm doing 11 and then 1 is 8 and then 1 is 1.
Sounds good to me.
It's correct.
Okay, you guys are just like barely there. Can I do x minus 3 quantity squared? Isn't that the whole thing is for me to complete the square and make it into something that can be written as a perfect square? What's the last step? To get standard form, you get everything to one side equal to 0. To get the clue form, the factored form. Do I want a 0 here or a 1? Should I subtract 144 or divide? Oh yeah, I want those fractions anyway, right? Get my A and my B, so divide. Everybody. Ugh. Now I have to simplify. Struggle. So then over here I do have my equals 1, which is exactly what we like. Go look at the blue form. I wonder if 9 and 144 reduces. 9 into 14, 1 times. 54, hey, that's 16, that's nice. Does 4 go into 144? 4 goes into 14 3 times. 2 left over, 24, 36 times. Huh. So I think I see x minus 3 quantity squared all over 16 plus y plus 5 quantity squared all over. Whew! Took us a little bit, but did we get to that nice clue form?
Oh.
We're done!
No, we're not.
So where we can start answering the whole question. Yay!
Oh.
Oh my gosh.
But it's all right there!
Somewhere.
It's right
equal to square
there. Okay,
I know 60 is actually over 4 squared.
yeah, we could do the center is who? Who's the center?
3 negative.
Yeah, 3 negative 5, because remember HK. X minus H, Y minus K. Who's our A? 6, he's the bigger one, but isn't he going to be vertical? Oh, that's good to know. Who's our B? He's the smaller one. 4, and he's going to be horizontal. How did I know that?
Because of these two, you know you have to set them.
Who is it related to? Good. Back to square root because it's a squared b squared. This one is related to the x. So I could rewrite, if you guys wanted to, I could rewrite this as 4 squared. I could rewrite this as 6 squared, if that helps. Seeing the a and the b. Now, didn't they also ask for foci? Oh, okay. Well, let's memorize. What was that formula that was at the top of the ellipse and it was squished this way? Or,
Squared minus b squared.
oh, well, you guys just needed a formula. Okay, that's true. That's true. So we have to define c first. So c squared is equal to a squared minus b squared. Oh, so c is equal to the square root of 20. That's yucky. Doesn't 4 go into 20? I never. Wait a minute, hold on.
2 is for
Benson P. Does anybody know whose class he is?
He has choir next period.
Benson.
Ben's.
Right now?
It is.
Go team. Kiddos, we know radicals, right? We know that's 2 root 5. Because the 4 goes in. Square root of 4 is 2. But still, does that get us our foci? Nope. Alright, let's go back to all those formulas that we better memorize because we don't have a graphical approach to this at all. You can. You can go back to your formulas and figure out what would the foci be. Or you could be like, wait a minute, hold on. Can't I graph this and maybe figure out where everything is? Either way. I could go 1 and a 2 and a 3 and I go 1 and a 2 and a 3 and a 4 and a 5. There's my center. How do I make my ellipse, cool kids? 6 is going to go what direction? Right, left, or up, down? Up, down. So I'm going to have to go, let's see, 1, 2, 3, 4, 5, and another one, 6. And then aren't they going to have to go 6 down? Go approximate. Right, left, how much am I going to go? Okay, so I'm going to go 4. 1, 2, 3, a little bit more, 4. 1, 2, 3, a little bit more, 4. I can roughly, emphasis on roughly since I ran over my page. I can roughly draw my ellipse, but how are we going to find the foci? Are they up, down, or right, left? Up, down, because they're always on the major. So 2 root 5, root 20, that's something a little bit more than 4. So 1 and a 2 and a 3 and a 4, something a little more. 1 and a 2 and a 3 and a 4 and something a little more. Kiddos, how do I get that point? Not K. Well, I mean, we could, but couldn't we, don't we already know our H and K? Isn't it 3, negative 5? Are we adding to the Y, or are we adding to the X if we're going up and down? Okay, so my top one is going to be 3, negative 5, plus 2 root 5. And what's my bottom one going to be? Yeah, negative 5 minus 2 root 5. Now, do you have to draw the picture if they don't say to? Oh, never mind, they say sketch it. You did it all at once. I guess you had to graph it no matter what. But do we know now all of our clues? Let's see, what are we supposed to find? Center, check. Vertices, well, we drew them. What would our vertices be? That just means on the edge of our ellipse. Do you guys know what this top point would have been? Good. Add 6 to the y value, because remember we're going vertically. So 6 is my A, add it to negative 5. So what's the one going to be on the bottom part?
Negative 11.
Negative 11. Good. We're going to have to subtract, right? So we're going to have 3, negative 11. What's our center vertices going to be? Our minor vertices. I think they might just be the major, but just in case. What would the minor vertices be? We'd add 4. What would the other one be? You would subtract 4. Now the good news is, guys, I really do think when they mean vertices, they really just mean the top and the bottom. So at this point, we can say, hey, we have the center check, we have that vertex, we have the other vertex, we have our focus, and our other focus. What's the one thing that we haven't written down that they asked for? Eccentricity. Who's that guy? I got you. Write down his formula. I know there's all this snazzy stuff about what he means, but it just means how spread apart the foci are, basically. Eccentricity. Write him down. Highlight his little box. All you gotta do is take your C and divide your A, and it's a ratio. Basically, the eccentricity tells you how elliptical, how squished, how oval an ellipse really is. I know, it's because I opened the door. I was warm before that. So long story short, the smaller E is, the closer it is to 0, the more circular, because the smaller the foci is. The larger C is, the more oval, the more elliptical, the more squished my ellipse will be. So in this one, if it's really just C over A, kiddos, how would I have found my eccentricity for this guy? That's it. 2 root 5 over 6, but if we want to be super snazzy, we would have reduced it to root 5 over 3. Kiddos, we got it. 10-3. Let's see how it goes for tomorrow. Bye, guys. Ta-da! There we go. See, it was right there. Happy nutrition. You made it. Go get food.
Jesse.
They're marked. I just need to do partial credit, and I'm really trying to finish it tonight. So you guys can get back to me. So, I had some TAs helping.